Hey, Pauline, I figured it out. Just being really silly. The question is, when will it be 20 meters above the ground? And again, here's the equation that we had. And we want to know when 20 is equal to an initial height of 0 plus 25 times t. Remember, the initial velocity was 25 plus 1 half times negative 9.8 t squared. The way I was thinking about it, I subtracted 20 from both sides and then drew the graph of the equation. That's not how she did it on her question, or that's not how she did it on the graph that she did. So, what the graph that she gave you on the test is what I'm trying to say. Sorry about that. So, what we should have done, or I should have done, is graphed this equation right here, actually two equations. And we could have simplified it because of the zero there, it just goes away, and done 20 equals 25t, 1 half times negative 9.8 is negative 4.9 t squared. So I'm going to graph this, and I'm going to graph 20 and see where they intersect. So if I go to my calculator, so we have, let me see, 25x minus 4.9x squared. It's a big, tall parabola, and we already know that from previous work, so I'm going to go up to like 40. And then I'm going to graph the line f of x equals 20. There it goes. So this is when the ball travels upwards. It's 20 meters high right here, goes up, reaches its maximum height, and then comes down, and it's 20 meters high right there. So I just need to find those coordinates, or the time that it did. So that would be at 0.993 seconds the first time as it's going up. And then as it's coming down, it will be 20 meters high at x equals to 4.11 seconds. So let me get that picture for you on the notes. Okay, so when would be, let's see, t equals 0.993 seconds, and that's on the way up, and then on the way down 4.11 seconds is when it would be that high. Okay, so I'm going to make that a little smaller. And then the question was, let me just extend the page a bit. Then the question was, label the diagram to show the relationship of these values. So this, I'm not sure how much labeling she wants, but this is the initial height, which in the equation is h sub 0. Oops, sorry about that. So that's h sub 0. I don't know if she wants that or not. You can't label the initial velocity, but we can do is right down here, this is, if this is the t-axis right here, this is the first time that it is 20 meters high, which we had to be 0.993. And then the second time would be 4.11. So that's all we could say. This question was right after this one, so that's all we could say about that. So when will the ball hit the ground? Well, if you go back here, remember this equation is when will the ball be 20 meters high? And we said, okay, 20 is equal to 0 plus 25.t plus 1 half times negative 9.8 t squared. So I'm going to get a picture of that because it's kind of relates to what we're going to do on this question. Okay, so that's what we had. So this is for E. So question E. When will the ball hit the ground? Well, the height of the ball when it hits the ground is 0 meters. So instead of 20, we're going to have 0 because that would be the height. Instead of 20 meters, we would have 0. So when does it equal to 0? 0 equals 25t minus 4.9t squared. Okay. And so we don't have to graph y equals 0. It's a little different on your calculator, but I think you'll agree that the height is 0 right here. It doesn't, this is where the football starts going. It's not on the ground, it's on the tee here. And then it goes up, 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 it comes down and hits the ground. So if we can find that, and on mine it's just find the 0, I think it's the same as on your TI-84. So you can see it's the coordinate 5.10 and the y coordinate is the height. So that's the time. So it hits the ground after 5.1 seconds. I'll put that on the page as well, just so we can see it. Okay. So t equals 5.1 seconds is when it will hit the ground because of this right here. At 5.1 seconds, the height is 0. Now use your calculator to find the highest height of the football. And I'm going to put that on a new page. It's getting a little messy. Now use your calculator to find the highest height of the football if the ball was kicked on the moon, where the acceleration for gravity for the formula is negative 0.8. It has already been halved. Okay, so then we would have to do this. Let me get this general equation again. Okay, so we have this formula. The highest height of the football, so we're solving for h, right? And that equals the initial height 0 plus the initial velocity was 25 times t, and the acceleration for gravity is negative 0.8, and it's already been halved. So I don't have to worry about this 1/2 here. It would be plus negative 0.8 t squared, or more simply, the height would be equal to 25t minus 0.8 t squared. So again, the maximum height, that would be at the maximum point of the parabola. So we just need to graph 25t minus 0.8 t squared, which I will do. Actually, I'm just going to get rid of all these things and just change this one from 4.9 to 0.8. That'll make it a little quicker. And that goes way up there, so I need to change my scale. And I'm going to change my scale here. And you can see it's going way up there, so I made my y scale 100. I'm going to go maybe up to 500. There we go. And so on the moon, the ball goes up, 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 hits its max and goes down. And it makes sense that it's a lot higher because it's on the moon, and gravity is less on the moon, so the ball will go higher. So here I just have to find the maximum point. And that happens in 15.6 seconds with a height of 195 meters. I'll put that on the thing here. Whoops, sorry about that. Okay, so we graphed it, and it says, is it when or how much? To find the highest height of the football. So the highest height is 195 meters. That's this right here. So the answer would be 195 meters. And they didn't ask it, but if they asked when did that happen, you could say, and it happened 15.6 seconds after the kick. All right, hope all that helped and really like working with you, and hope to work with you again soon.